Hello everyone. I hope all of you enjoyed the quiz. Permutation combination is one of the most complicated topics that is tested on the GMAT. So obviously, I'm sure you would have gone through a lot of great questions and enjoyed the quiz. So now is the explanation time. You guys will learn how to solve these questions. If you have doubts around it, all those things will be clarified today. Okay. So just before I start, I'll just give a quick introduction about myself. Those of you who don't know me, I'm Piyush Beriwala from GMAT Viz. I have 11 years of experience now. I remember I started teaching and helping people get into top B schools across the globe almost 11 years back. And it has been 11 years I've helped people ace the like tests like GMAT, CAT, and help them get into MBA programs globally. I remember like it was 10 years ago when one of my first students got into Stanford. So you think of any top B school, I've helped people get into top B schools across the globe. I have prepared for both GMAT and CAT and taught for both the tests myself. I scored a 740 on GMAT in the previous version, and I scored a 99.9 percentile on CAT. And personally, I like analyzing trends and data to come up with strategies. I'm a quant and data insights expert, and certain parts of verbal also I've taught in the past. But yes, more of a content data insights expert. So yeah, I think analyzing trends and data to come up with strategies is something which comes naturally to me. So that's a quick introduction about me. Overall, I work for GMATWiz. I'm one of the co-founders of GMATWiz, and we're going to learn a lot about probability, permutation, combination, a lot of new things also. I'll try to teach based on the questions that we had basically today with us. Okay, so let's get into it. Let's get into the first question directly. Okay, now I saw some of you, Natasha, I think Apurv, Shivam, and Prachi. I think these are the four people who did really, really well. A lot of you scored above 500. So congratulations for that. Great job on that. But let's still see if the process was the best and can you improve the process further from there or not. So let's start with this first question itself. So this is a straightforward question. It says, how many six-digit code numbers can be formed from three A's, two B's, and one C? Now, whenever the question is in that format, like three A's, two B's, and one C, you know that exactly three A's have to be used, exactly two B's have to be used, and one C has to be used. So since there are like total six entities that have to be arranged, I can arrange them in six factorial ways. Now that is something we teach at GMAT Viz. It's called the filling spaces method. Basically, where for the first place I have six options. I can pick any of the three A's, any of the three two B's, and one C's overall. Just 1 second, guys. I'm just gonna mute. Yes, so guys, those of you who are saying that the video has stopped, there's some technical glitch, I guess. Just refresh the video. Just refresh the video, refresh the link, and it will start working fine. So the video is all fine. I got a call from the GMAT Club team, and they informed me that for some people, it's showing that the video has stopped. Just refresh the video, and all of this will work fine. Okay, just like magic. Okay, so yeah, refreshing is restarting sometimes just helps. Okay, I'll just text here as well, uh, so that those who can't hear me, for those who, okay, I'll just write text it here, guys. Yeah. Okay, so coming back to this. So this is the filling spaces method, some very basic thing, like six spaces to be filled. For the first place, I have three A's to choose from, two B's and one C. All six options are available. Next place, I have five options. If I place, let's say, A here, then I'm left with two A's, two B's, and one C to pick from. Then I have five options for the next place. Let's say I place a C here, then I have four options for the next place, and so on. So again, a very basic concept. I just thought I'll just tell you uh, overall. So it's 6 factorial. That's the total number of arrangements. But since there are three A's which are exactly same, we have to dearrange those arrangements, and two B's who are exactly same, we have to dearrange those arrangements as well. Because whenever you have something similar repeating, you need to divide by the arrangements between them, because in the total arrangements, that arrangement is also being considered. It's like when you are writing 6 factorial, you're assuming that those three A's are unique, like A1, A2, A3. But since they are same, you have to divide by 3 factorial and 2 factorial. And if you solve this, you will basically, you can solve it like this. Overall, 2 factorial is 2, so 3 factorial gets cancelled. And if you calculate this, you get 30 times 2, which is 60, and C is the correct answer over here. Okay, so fairly straightforward question. I would say sub 555 level question overall to start with. Now let's move to the next question. Now this is a question which is on coins. Again, coins is one of the common type of questions that are tested on GMAT probability, especially in probability questions. So it says a fair coin is flipped 3 times. What is the probability that the coin lands on head exactly twice? So I need 2 heads and 1 tail. Okay. Now, if I look at this event, HHT, 2 heads and 1 tail, then the probability of 2 heads is basically half into half, which is half squared, and the probability of a tail is half again. Okay, so that's the probability of this particular event, HHT. But there are several other cases also where 2 heads can be there. How many cases are there? Again, I'm just writing it down. You don't have to write it down. There's a mathematical way of finding the ways also. But there are these 3 different ways in which the same event can occur, which is 2 heads and 1 tail. Now, how do you identify that? Very simple. You have 3 things to arrange, right? That can be arranged in 3 factorial ways, and 2 of them are same. 2 heads are same. So that is 3 ways of doing it. So the answer would be half squared into half into 3. Okay. So please make sure that you do that. And again, this is one way of thinking. Okay. So you have HHT happening in 1 by 8 ways, and the same goes for this, and the same goes for this, basically. So 3 different events, each of them having 1 by 8 as the probability. So my total probability is 3 by 8. Okay. And sort of, you're right. You can also think in that way. If you want to think in that way, that which 2 coins will have heads on it out of the 3 coins. So you can also say 3C2 into 1 by 8. Both are same. Both are the same. Both are the same thought process. Now, in this question, this is a very straightforward question, nothing complex about it. But sometimes people make this rookie mistake that they don't multiply by 3. They just do half squared into half, and they say 1 by 8 is the answer. And that's a trap, basically. Understand that your arrangement will also become important, because 2 heads and 1 tail can happen in 3 different ways on a coin. Now, one more thing which I'll tell you, again, this is something which you might not have thought of, but even if the coins are exactly same, let's say here we are tossing a coin thrice, so you can understand when the heads are occurring and when the tail is occurring. Okay, we can differentiate because it's flipped thrice. But even if you flip 3 coins at the same time, 3 identical coins at the same time, okay, even then you have to multiply with 3 here. Because please understand that the event of 2 heads and 1 tail occurring can still happen 3 times. Like 3 different scenarios are there. You might not be able to discern this from a human eye, that okay, the coins are identical, I'm flipping all of them at the same time. I can't differentiate between which coin is what, but that doesn't mean that the chance of the event happening will reduce. Okay, so it will still be multiplied by 3. In probability, there is all the things are always distinct, like basically. So it's a chance that we are talking about. Okay, so we multiply by 3 here to get the answer. Now, I have created a variation of question 2 because I wanted to teach an important lesson from this question as well, which is really helpful in solving a lot of other questions. So I want you to try this question and tell me what is the answer, guys. Okay, I'm giving you, since you've solved this question, similar question here earlier, so I'm giving you about a minute and a half. The only change I have made here is that instead of the previous question was asking how many times heads can happen exactly twice. Now I am asking in how many, what is the probability basically of the heads occurring exactly at least twice. Not exactly twice, but at least twice. Okay, that's the only change that I have made. All right, guys, I wanted to do this one. Saurav already has the answer. Shivam and Sid all have the answer. Great. Faith also has the answer. Great. Half good. But I'll teach you a better way to kind of come to the answer. Okay, so let's solve this together. I guess you guys have tried it. So see, when I have at least two heads, it means I can have two heads, one tail, or I can have three heads, zero tails. So this we have already calculated. The probability of this is 3 by 8. This one will be half cubed, which is 1 by 8. You add both of them, you get 4 by 8, which is half. Okay, so that's one way of doing this question. But the reason I've given you this variation is for a different reason. I want you to understand something more conceptually here. So let's write down all the events. When we flip a coin three times, what are the possible events? I can have 0 head, 3 tails. I can have 1 head, 2 tails. I can have 2 head, 1 tails. Now focus on this event also. The probability of this event will be 1 head I can get in half ways, 2 tails I can get in half to the power half. That's the probability. And then again, I have to multiply with 3 factorial by 2 factorial because I have to arrange 2 tails with a head. Okay. So that's three things to be arranged. 3 factorial ways I can do that. And 2 of them are same. So divided by 2 factorial. So it is again 3 by 8. Now, if you observe carefully, these two events, second event and the third event, have the same probability. You can see that mathematically they have the same probability. But logically also, you can understand that they are supposed to have the same probability simply because head and tail in a fair coin are equally likely events. Both of them have half the probability, half the chance. So whether it is 1 head or 2 tail, or 1 head or 1 tail, basically to the coin, it can't differentiate it. The probability is going to be the same. Here I have 1 head, here I have 1 tail. Here I have 2 tails, here I have 2 heads. So it's exactly supposed to be exactly the same case overall. With this, using the same logic, I can say that the probability of this event, the event 1 and event 4, will also be the same. Let's call the probability as B. Then that probability will also be the same. Now, why is this important? What you need to understand is that if that is the case, if I split the events at the center, if I split it into 2 parts, I know the probability of the top part is A plus B. The probability of the bottom is also A plus B. They are equally probable. So the bottom part is half. The probability of the bottom part happening is half. So this question I don't even need to solve. The moment I see that there are 3 coins being tossed, and I know that they are asking me the probability of heads occurring at least twice, which is splitting all the cases into 2 equal parts. I know that each of the parts probability is half. I don't need to do any math at all. Got my point, guys? If you got my point, just say a yes. That will be really helpful. Okay. So just to be clear, if they're giving me the question that there are 5 fair coins, okay, it's important that the coins are fair because the probability of head and tail should be equal, same. So 5 fair coins are tossed, and they ask me what is the probability of getting at least 3 heads or 3 tails, at least 3 heads, let's say. My answer should be half right away, because understand, in 5 coins, if I split at the center, there are going to be 6 cases. If I split at the center, at least 3 heads will be exactly the bottom 3 cases. How do I know that? Because center point or the median is always n plus 1 by 2. Okay, so if there are 5 coins that I'm tossing, 5 plus 1 by 2, which is 3, is the median. So 3 heads is the median, 4 heads and 5 heads, those 3 cases will be in the bottom, basically. So you can say 0 heads, 1 head, 2 head, 3 head, 4 head, 5 head. You can clearly see that this is the median, basically, and this is half of the cases. So they can give you 5 coins, ask for at least 3 heads, their answer is still half. You don't have to do any math, okay, if you understand the logic behind this. And this will work for other cases, some other cases also. Like, for example, if they tell you that 5 dice are rolled, and what is the probability of getting an even number on at least 3 dice? Now, the probability of getting an even number on a dice is also half, and non-even number is also half. So if it's the same thing as a coin in a way, basically, right? It's getting the same outcome. So if you're rolling 5 dice, basically, and you're asked what is the probability of getting even number at least 3 times on 3 dice, basically, it's going to be half again. Okay. So the same logic will work. Again, I can't go too deep into explaining it because this is not a permutation and combination class. Like we explain this in our course and obviously in our private tutoring sessions as well. But this can really be helpful in you solving the question a lot faster, basically. Okay. So let's move ahead then, guys. Let's move to the third question. Now, this is the first data sufficiency question, basically in the quiz. Now, DS questions on permutation, combination, and probability are comparatively rare compared to the other questions that we get on DS, like which are more word problems and statistics-based questions. But yes, still there could be some questions on permutation, combination, and probability. By the way, this is more of a statistics question, so this is definitely a very common question type, I would say, that you can expect on the GMAT. Now, if I look at this question, let's see. It says a power plant operates 7 days a week. What is the median amount of coal consumed by the plant in the last week? So I need to have the median. So if I arrange the median amount, the amount of coal consumed by the plant in ascending order, basically the fourth one, basically, if this is on 7 days, this one will be my median. So it has to be arranged in the ascending order. All right, guys. Now, I don't have any other data. I know that the fourth one is going to be the median. I'm not saying day 4. I'm saying if the coal consumption is arranged in ascending order, the one in the center is going to be my median. Now, if I look at the first statement, the plant consumed 560 tons of coal last week. That doesn't tell me anything. Like I can't assume that the coal consumed was equal on all days. No such assumption can be made. 560 can be distributed in several different ways. So this statement is not at all sufficient to answer the question. Now, if I look at the second statement, it says the plant consumed 70 tons of coal during each of the first 3 days. So I know D1, D2, and D3 is 70. Okay. But does that mean this is the lowest 3 consumptions in the ascending order? I don't know that. It could have started consuming less. Again, I'm just analyzing statement 2 alone. So if I look at statement 2 alone, I can't infer anything from this. And it is only telling me about 3 days. It is not even telling me about the fourth day or anything. Had it been the plant consumed 70 tons of coal on 4 days of the week, okay, on 4 days of the week, you can be very certain that 70 is going to be your median. Because if it is consuming 70 tons of coal on 4 days of the week, 70 will definitely come in the center. There is no way you can arrange them in ascending order without keeping 70 in the center because it's more than half of the days, basically. So in that case, it would have been sufficient, but it says it is coming on first 3 days. It's not saying first 4 days or on 4 days. So this is still not sufficient to answer the question. Now, if I combine both the pieces of information, I know that on day 1 to day 3, it consumed about 210 tons of coal. So day 4 to day 7, they would have consumed around 350 tons of coal. Now, how did they do this 350 tons? What was the exact distribution? I still don't know it. It's possible that I could have had 70 on one of the days, and on the remaining days, 280 tons could have been happened in 90, 90, and 100. So in that case, 70 would be my median. It is possible that it was 80, 80, 80 on a few of the days, and on another day to just balance it out, it was 110, basically. So in that case, 80 ends up being my median. So I'm getting two different answers for the median, even if I combine both the pieces of information together, and hence this question cannot be solved even by combining both of them together. So answer is going to be E. So in DS question statistics, if nothing works, you can try to prove it insufficient by taking 2 scenarios. But one of the key learnings in this question is, which is going to help you in the GMAT a lot, is if the second statement, if it said that each of the first 4 days of the week it was 70 tons of coal, then statement 2 would have been sufficient. Again, in the current state, it is not, but if I make a change to the question, it can be. I'm just telling you this for learning purpose. The correct answer in this case is definitely E. Okay, guys. Now that's like the first 3 questions done. Now I focused a lot in the last session that I took about a couple of weeks back on the fact that in quant, if you want to really score high on quant, how important it is to things like smart, because with the new GMAT coming in, there's a lot of scope in terms of quant improvement. If you push yourself, you can improve your score by 60 points in the overall score by moving from 76 percentile to 100 percentile in the GMAT focus edition. I talked about this a lot, and I also focused on the fact that you would need some questions in quant, and even in DI for that matter, will require some extra time, as you can see on the scorecard of some of the students who have done really well in these tests. But these people were able to save time from the remaining questions. So it's important in GMAT to have conceptual clarity, use smarter logical methods, and also be aware. So I talked about these two aspects a lot in the last session. It was on the time and distance, time and rate. It happened a couple of weeks back. You'll find the recording on GMAT Club itself, like YouTube channel itself. You can watch it out to learn some of the great strategies we talked about that day. Today, I'm going to focus a little more on the awareness angle also, because we have a few questions where we can use the awareness to kind of awareness aspect to kind of get the question right in a slightly shorter period of time also. Okay, so I'm going to focus on that part as well. So get to question number 4. Now, this again is a question where an important like formula can be used. In PNC, favorable cases can be written as total cases minus unfavorable cases. So whenever you're solving a question in PNC, it's very important that you take a step back and strategize whether the favorable cases are going to be more or the unfavorable cases are going to be more. If the favorable cases are going to be much more than the unfavorable cases, it is better to do the unfavorable cases, because that will take you less time to compute and subtract it from the total cases. If you think favorable cases are going to be less, you can calculate it directly. So in this case, for example, if you see, it says that in how many ways can these 4 people be arranged such that C and D don't sit next to each other. So I can just take out the total cases, basically, which is 4 factorial, because I have to just arrange all 4 of them in a row. And then I can take out the case when C and D are next to each other, basically. Okay, and that's my answer to the question. Okay, so that's my answer to the question. So when C and D are together, I can consider them as a single unit, basically, and AB are different units. So I have now 3 people to arrange in a way, which can be arranged in 3 factorial ways. And C and D can themselves be arranged in 2 ways, or 2 factorial ways, whatever you want to call it, because it can be CD or DC. They can sit in 2 different orders. So my answer is going to be 4 factorial minus 3 factorial into 2, which is 24, minus 3 factorial is 6 into 2, which is 12. So I get my answer as 12. Okay. So the learning in this question is that favorable cases sometimes can be calculated by taking the unfavorable. Now, obviously, in this question, it was easy to use this concept. It was very natural also, right? But GMAT sometimes puts a trap in these questions where they make it slightly more difficult for you to predict that you should be using the unfavorable case rather than the favorable case. Generally, the unfavorable case thought gets triggered when you see at least or at most those kind of statements, or negative statements, like over here it says C and D not sit next to each other. But there are some traps where GMAT will test your understanding whether you use this favorable and unfavorable thing or not in a slightly different way when you don't expect it to be. And I'll give you an example of that as well as we do the next question. Okay, not in the next question, but I'll give you a variation of the next question. But let's first solve this question. Okay, so this one I feel is a mix of probability and number properties understanding. So if I look at this question, it asks me if one number is selected at random from A and one is selected from B, what is the probability that both are primes? So first thing you have to identify is how many of these are prime numbers. So if I look at this number, 71 is a prime number, 73 is a prime number, 79 is a prime number, 83 is a prime number, but 87 is not a prime number. Similarly, in this set, 57 is not a prime number because it's divisible by 3. These 3 are prime numbers. So if I look at the probability of both being prime, let's call it X and Y. Okay, X is picked from this and Y is picked from this. So the probability of X is prime and Y is prime is nothing but the probability of X is prime multiplied by the probability of Y is prime. Because they are independent events. They don't have anything to do with each other. They are independent events, so I can just multiply their individual probabilities. So what is the probability of x being prime? There are four numbers which are prime numbers out of the five, so it is 4 by 5. And in y, there are three prime numbers out of the four total numbers. I can do this, cancel this out, and I will get the answer as 3 by 5. So slightly straightforward question, not too complicated. But yes, it does test your skill on identifying the prime numbers before you solve the probability angle. Sometimes people just in a hurry solve this question. So don't make that mistake. Now, I'm giving you an additional question, which is a slightly altered version of the current question. So again, we have two sets, A and B. One number each is picked from each set. I've changed the sets a bit. So the first set A is the set of all perfect cubes from 1 to 1000. Okay, just to be clear, in the test it will be written, this statement will be written, but I didn't want to change the question. It looks similar, so I kept it like that. But A is the set of all perfect cubes from 1 to 1000, and B is the set of all positive integers from 50 to 69. Now the question is asking, if one number is picked at random from set A and one number is picked at random from set B, what is the probability that the product of the selected numbers is even? Okay, this is an additional question which I am giving you just to help you enhance your learning and take it to the next level. Can you guys solve this and tell me what will be the answer? Again, I'm not giving you the options here. Okay, so I want you to put in the effort and calculate the answer here. Okay, but more important thing for me, honestly, is your process of solving. I'll definitely focus on that a lot more than this. But still, I want you to solve it, try it, and tell me what you think is the answer. Yeah. Let's see. I'll give you a minute to solve this. Yeah. Okay. Shravya has the answer. Shravya says 1/4. Okay. Let's see, Shravya, if you've gotten it right. Natasha says 3/4 with a question mark. Okay, good. Shravya, I can tell you without even looking at the answer, using the logic that Natasha is using, it can't be 1/4 for sure. Has to be closer to 3/4, as Natasha is saying. Reason we'll get to see, but has to be closer to 3/4, not exactly 3/4. Okay. Another 30 seconds, guys, and then we solve this together. But more important than the answer is the process, basically, for me. And for you guys also should be the process, because that's what you'll get into the answer faster. Okay, let's wait for a few more responses. I'll get just okay. So I have a response from Rugved. He says 29 by 38. Most likely that's correct. But yes, let's still I still need to calculate it. I just created this question 10 minutes before basically joining the session. Sid says 3 by 4 should be close to 3 by 4, Sid. I agree with you. The logic you're using is right if you're using that logic which I'm thinking you're using, which I think Natasha also used. Harsh is also using the same logic. Is not 3 by 4, guys. It's definitely not 3 by 4. But it's close to 3 by 4. That's for sure. Yeah. Those of you who are using 3 by 4, they are saying that, okay, if I'm picking two numbers and they're like equal number of even numbers and odd numbers in both the sets, then the chance of it being the product being even is 3 times the chance of it being odd, because like that's how it works. Like two odd even numbers gives me an even number as an outcome. One even number with an odd number also gives me an even number as an outcome. One odd number with an even number also gives me an even number as an outcome. But one odd with odd gives me an odd as an outcome. So that's just one case. The other 3 cases will always be even. So those of you who are taking 3 by 4, most likely are using that logic. There's a small problem with that logic here. You're assuming that exactly same number of even and odd numbers are there in both the scenarios. If that's the case, then yes, 3 by 4 will work. If that's not the case, then it won't work. So in this scenario, I think 3 by 4 is the answer eventually, because there's the same number. But like there was an official question where this 50 was not there. So the answer is actually different in that scenario. But anyway, doesn't matter. The answer is not important for me. The process, more importantly, is going to be crucial here. So let me solve this question. And just for the sake of learning, I'm going to take out 50. Okay, I'm just going to take out 50 here because I don't want you to just, you can use that logic with 50, the 3 by 4 logic, which will work fine. But if it is 51, let's see how we solve it instead. Okay, so let's do this question. So when I was doing this question for the first time, again, the numbers were slightly different, basically, than this, obviously. When I was doing this question for the first time, my first instinct was that, okay, I don't see the same number of even and odd. Definitely, I can't use that logic that like was being used by so many people here, because in set B, if you see, it starts with the odd number, ends with the odd number also. So there is more odd numbers than even numbers. So I can't directly use that logic. If that was there, then obviously I can use that logic. So Rugved, if 50 is removed, then 3/4 won't be the answer. With 50, the answer is 3/4. I stand corrected. I did a very quick calculation, but now if 50 is removed, then 3/4 won't be the answer at all. If 50 is there, then 3/4 will be the answer, because then both the sets have equal number of even numbers and odd numbers. Okay, but let's understand this. I know some of you are thinking logically more, which is a good thing. I really like it, but there are other people also who need to understand this. So I'll just solve this question in a step-by-step fashion for them first. Okay, so when I saw this question first time, I saw clearly in set B, there is not equal number of even and odd numbers, so that logical work, like logical like thing 3 by 4 will not work. So let's do this. So I started to think that, okay, product of xy is even, then I should write x is even and y is odd plus x is odd and y is even plus x is even and y is even. This was the first thought that came to my mind. Obviously, like in a test mode, I was doing this in a test mode. So it came to my mind that I should be doing this first. But the moment I thought of it, right at that moment, it clicked that why am I writing three scenarios? The three scenarios will take me a lot longer to calculate. Why not simply write it as 1 minus the product of x by being odd? Right? That's much better, because the only case in which the product of xy is odd is when x is odd and y is odd. So I can simply find the probability of this event and subtract it from 1, and I'll have my answer. Now, some of you might think, how does this help? It does help. If you do the other one, the first one, you take 3 different scenarios, you'll end up spending at least 50 seconds to a minute extra to solve the question, because you'll have to make 3 different calculations. In the second case, you might need to spend 10-15 seconds to strategize, but you will actually save a lot of time in the calculation. So it's not just time that you're saving. You're also going to save a lot of your energy and stamina, which will help you in other questions. So I hope this is clear, guys. So if you understand this, we just have to calculate the probability of x being odd. Now, x being odd, x is basically the element that I selected from set A. So there are 5 odd numbers out of 10 odd numbers there. So it's 5 by 10 or 1 by 2, whatever you want to write it. In the second one, if you see in set B, there are total of 19 terms, out of which 10 are odd and 9 are even, basically. So again, using my series understanding, I'm just doing that. So the number of terms I can find, for those who don't understand this, number of terms I can find by saying 69 minus 51, largest minus smallest, plus 1. So that will give me 19, which is the total number of terms. If you want to find the total number of odd numbers, you have to divide it. The odd number is coming at every second term. So you can calculate this. It will come out to be 10, basically. Okay, this is how I do the math. So if you calculate this well, I'll just erase this part quickly. Like it's a series related concept. I'm assuming you guys know it. So I can just calculate this 5 by 19. So my final answer is going to be 1 minus 5 by 19, which is going to be 14 by 19 in this particular case. Okay. So again, this is the answer with 50 not being there. The second set is starting from 51 to 69. If the second set started from 50, the answer would have been 3 by 4. You can use logical reasoning, or you can use the same method here and do the math. You'll get the answer as 3 by 4. But in this case, answer is 14 by 19. But the reason I gave you this question is not for the answer. Let's not worry about the answer. The reason I gave you this question is to understand that generally when you look at the case when favorable cases, the equation when favorable cases is equal to total minus unfavorable, that thought gets triggered when you see at least one, at least two, those kind of situations. But in cases like this also, you should be open-minded. Like when the product, they are saying XY product is even, you should not try to take three scenarios and find the direct value of the favorable cases. It is better to find the unfavorable case, which is product of xi is odd, because that can only happen in one situation. So what I'm trying to say is that this is what I mean by awareness. You need to be very aware. It's like a game. Imagine you're playing Call of Duty, okay, or any game, video game that you want. You're shooting at your enemy. It's not like you're just aiming at your enemy and looking at the enemy. You're still also watching your surrounding, if there is anyone else who is going to attack you or not. It's like that in the GMAT. Treat it like a game. Like I remember one of my students, Keshav, who scored a 705 and finally got into Yale. When we were doing his debrief, he talked about this aspect, that how he started looking at GMAT as a game, basically. That there are so many things which can happen, and you have to be in a very heightened state of awareness at that point of time with an open mind to see what's happening around you. That's what I call this. So you might as well be kind of like too quick to judge that, okay, I just take three cases and solve it, but you need to take a pause and strategize. And that's very, 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 very important. Before you solve a PNC and probability question, before you commit to solving a PNC and probability questions, do strategize. Think about what is the best way to do this, because there are usually two or three ways to do a PNC and probability question. And again, strategizing is a skill which is very important in other areas like algebra and number properties also. Uh, but between PNC and probability, that's super critical. Like there are so many official questions that I've seen where if you just sit and like look at, observe the question and strategize for 10-15 seconds, you will not just save a minute. In this question, you can save a minute, but in those questions, you can even save 4 to 5 minutes by just observing and simplifying the question stem. And there are like better methods, obviously, that can be learned, that always I have to talked about, basically. But this is what I meant by awareness overall. Okay, guys. So let's do this next question then. Let's move to the next one. Spend a lot of time on the fifth one. I just wanted you to have that lesson. So let's do this one. It says balls X and Y contain exactly two jelly beans, each of which are either red or black. So I don't know whether the two beans, let's call it bean one, bean two for this one and this one. I don't know the colors, but they're red or black. One of the beans in ball X was exchanged with one in Y. After the exchange, the were both of the beans in bowl X black. So again, they are asking whether after the exchange it was black or not. Basically, let me write it like this. Let me just do some erasing here. Let me use a pen. So let's say this is the before scenario and this is the after scenario. So they're asking after the exchange, were both of these black? Again, right now I don't have any information whether initially what was it with to start with. So let's go directly with the statements. I go to the first statement. It says before the exchange, bowl X contained two black jelly beans. Now, if before the exchange it had two black jelly beans, will it have two black jelly beans even after the exchange? Now, the answer to the question depends on whether it was exchanged with a black one or a red one. If it was exchanged with a red one, it will not be true. But if it is exchanged with a black one, it will be true. So this statement gives us two different possibilities, definitely not sufficient to answer the question. Okay, so I'll just take off this piece of information from statement one from my chart paper or presentation. Now let's look at the second one. After the exchange, bowl X contained one jelly bean of each color. So it says after the exchange, one was red and one was black. Now that talks about bowl Y, not X, sorry, bowl Y. Now I don't know which one is the one which is coming from X, whether it was the red one which was coming from X or it was the blue one which came from X. And I also don't know what is happening with bowl X at all. So this piece of information doesn't help either. Now, if I combine both pieces of information, I know that earlier in bowl X, there were two black jelly beans. And now in bowl Y, this is a question mark again. This is not still confirmed. Now in bowl Y, there is red and black jelly bean. Now, there are still two possibilities. It is possible that the jelly bean that was basically exchanged was a black one, basically. and the other jelly bean was red initially in Y itself, in that case I'll get both black. Or it is also possible that there was a red jelly bean in the here, which was explained with a exchange with a black jelly bean here, and that way basically we will end up getting a black jelly bean in Y after the transfer, and a red one is basically this one which is already there. Okay, but in that case I will end up with X as B, L, R, and R after the exchange. So both the like options exist. So even if I combine both statements together, I cannot answer the question. So answer will be E. Okay. Now let's move to question number 7. Now this is a really good question. Can be solved in multiple ways. Okay. So one of the ways to solve this question is the classical way, where you can say that there are X bottles of 20 ounces, and you have then 48 minus X bottles of 40 ounces. If you multiply this, you should get 35 into 48, which is the average. Or you can say, if you want to use the weighted average concept, you can write it like this as well, basically, and you can solve it from here. Again, you can solve for X from here and you get the value of X from this, and then you can use another equation for the second statement as well. Okay. So again, if you want, like I can tell you what will X be in this case. If you solve, you'll get X as 12. Then the other equation would be that if certain number of, let's say, bottles are taken away from 40 ounces, bottles are taken away. So let's say the new number of bottles is Y. If I divide that by X plus Y, I should have 25 ounces as the average. I know it is 12, so I can replace the value of 12 here. So I'll get the value of Y from this, basically, and then I can identify how many bottles were reduced. So that is one of the ways of solving this question. Okay, but that's a very regular, very classical way of solving this. You can solve it that way. If you want, I can show you the solution and everything. But I'm more interested in teaching you a better method of doing this, which is a more logical and a more faster way of doing this, which is called alligation. So the alligation concept is very simple, basically, and it can be very handy in several quant and DI questions especially. So what this tells us is that if you are having two size bottles, 20 and 40, and their average is coming out to be 35, basically. Okay, then you just look at the difference between one of the bottles, like one of the sizes, and the weighted average. So this difference is 15. It just make it here, and the difference between these two is 5, basically. You just look at the difference. Okay, so the bottles should be mixed in the ratio of this 5:15, which is 1:3. Okay, that's a very, very simple way to solve this question. You don't have to write any equations at all. So the idea is that 20 and 40 are the sizes of the bottles. Those two are mixed together. The average size is 35. So you can use the alligation concept and find the ratio of the quantity of the bottles. So if it is 1:3, and you know there are total 48 bottles, you know that if this is, I can write it as ratio, I can convert to numbers by taking the common ratio as K. Then I can say 4K is 48. So from there, I'll get K as 12. That means earlier I had 12 bottles of this and 36 bottles of 40 ounces. Okay. I hope this is clear to all of you. Let me just erase this part from the slide. Okay. Now, there's a second scenario. What is the second scenario? Second scenario tells us that some bottles of 40 ounces are sold. Now, there is 20 ounce bottles and 40 ounce bottles. Now the average is 25. Now, if the average is 25, look at the difference between 20 and 25 is 5 still. This difference is 15. That means this is the ratio of bottles now. Okay. Now, this is same as 3:1. Now, I know there has been a change in the number of bottles of 40 because it is 40 ounces because it isn't sold. But there are still 12 bottles of 20 ounces because no 20 ounce bottle was sold earlier. Okay. So I know this 3K is basically equal to 12. So I can calculate from this K is equal to 4. You can call it K2 if you don't want to confuse yourself with another K being used. So K2 is equal to 4. That means there are now 4 bottles of 40 ounces, basically. So if there are 4 bottles of 40 ounces instead of 36 bottles, we should have sold 32 bottles of 40 ounces. Basically, that's the idea. Okay, just give me 1 minute, guys. It's something urgent. 1 minute. Sorry, guys. So I'm back. Okay. So again, the allegation method can actually make this question a lot more simpler. So I have a question on Tasha, how to be smart to identify allegation questions. Again, allegation questions, you have to understand the core principles. Allegations can be used for solving a lot of word problems. Like it can be used for solving percentage questions, interest questions, time and work, time and speed, almost all word problem questions. Wherever you are mixing two entities. You're mixing two entities. You have two subgroups, and you're looking at a combined parameter of those two subgroups when the two subgroups are combined into one. Like for example, if you let's say talk about the interest received from one let's say investment and the interest received from another investment and the net interest, the total interest received from the two investments combined. There also you can use allegations. If you talk about, let's say, a factory having two costs, raw material cost and labor cost. Let's say there's a percentage increase in the cost of one entity and the percentage increase or decrease in the cost of another. What is the net increase in the percentage? There also you can use allegation. So allegation is a concept is not just used for averages. Please understand that. It is also used for looking at a parameter, which is a combined parameter, has effect drawn from two different subgroups of it as well. Okay, and again, I generally teach this a lot in our sessions when we do discuss this, and this really comes in very handy. You can literally read the questions and solve it very fast using allegations, and it comes in very handy for DI. More importantly, I've seen the application of it happening in DI than quant, basically. So yeah, we do teach it in our GMAT course, and obviously in our sessions also we teach. But yes, you're a very valid question. How to be smart to identify allegation questions? This is the way to think. You can think in this way, and obviously. With more practice you'll get better at it, and you'll have to understand how this works, so you have to expose yourself to this kind of questions. So as I said, like this is what I was telling you about. So we looked at awareness, how important is awareness, through the question where we talked about the product being even, right? How to look at unfavorable cases even when it is not very normal to think of unfavorable cases, and we looked at a little bit around how to use smarter logical methods like allegation to solve questions better, faster. Okay, now let's move forward to question number 8. Now this is a question which is some people basically use conditional probability to solve it and whatnot, but let's keep it simple. I'm not going to use conditional probability. I don't want you to be confused with conditional probability. For GMAT, honestly, you don't need to know what conditional probability is. Just understand the question, you'll be able to solve it. So the question says, Harry flipped a coin until he got tails. Okay. So once he gets tails, he stops. That's important. If Harry stopped after no more than 3 flips, so the total scenarios that we have to consider is maximum of 3 flips. So in 3 flips, what all can happen? So basically, he can get a tail in the first flip. He can get a head in the first flip and then tail in the next flip. He can get a head first flip, he can get a head in the second flip, and he can get a tail in the third flip. So if he stopped after no more than third flips, that means the total cases are limited to these 3 only. We are not talking about the case when after the third flip also he's not continuing after the third flip. So we are only looking at these 3 cases. So if he stopped after no more than third flip, that means within 3 flips he should have gotten a tail. Okay, so that is going to be a total scenario. Now they're asking what is the probability that he didn't get tails until his third flip. So they're asking the probability for this one. So let's say if the probability of this event is A, this is B, and this is C, they are asking the value of C divided by A plus B plus C. Okay, is that clear to all of you? I hope that is clear to all of you guys. That my total sample set is these events. If I assume the probability of each of them is A, B, and C, total probability will be A plus B plus C, and they're asking me for the probability of the third event. So that will be C by A plus B plus C. Okay, if that is clear, let's write down the probabilities of each one of them. So what is the probability he gets the tail in the first flip? Obviously, it's a fair coin, so it will be half, simply half. Okay, what is the probability of he getting the heads in the first flip? It's also half, multiplied by heads in the second flip. So it's 1 by 4. What is the probability of the third event? Heads in the first flip, half, second flip, half, tails in the third flip, one by 2. So 1 by 8. So I have to just do this math, right? Now, if I calculate this, 1 by 8 divided by 8 over, sorry, 4 plus 2 plus 1 over 8, which is 1 by 8 divided by 7 by 8, which gives me 1 by 7 as the answer. Okay, guys? So no need to use the conditional probability formula, honestly, here. If you want to use it, you can. Totally up to you. But I don't recommend, I don't teach conditional probability to my students unnecessarily. I've never seen a GMAT question where you need to use that. Just understand that if they have given a particular situation, like it's very clearly mentioned that if Harvey stopped after no more than 3 flips, that means the total cases here is limited to the 3 flips, and he has definitely gotten a tail in the third flip, at least in the third flip, latest in the third flip. That's what we need to understand. That's my total cases. You don't need to use conditional probability then at all. Okay. Now let's do this question. Now this is another good question of awareness, like how awareness can easily save you about a minute, if not more, basically. So when I saw this question, very clear, 1522 numbers are there. There's one mode, and the mode repeats 12 times. That means the other numbers are 1510 numbers. There are total 1510 numbers. If I take out the mode. Now, no number occurs fewer than 2 times. So every number is occurring 2 times. So a number can occur 2 times, it can occur 3 times, it can occur 4 times, all the way till 11 times. Because the mode I have already taken out and adjusted for it. Okay. Now the question is asking me, what is the range of the number of unique numbers that could be in the set? Now, range of number of unique numbers. Now you have to decipher this also. Like some of the people, some of them, when you read this fast enough, you don't understand what it is asking. So it's asking me the range of what? Range of number of unique numbers. Now, how many unique numbers will be there? So if every number is repeated twice, then there would be these many unique numbers. On the extreme end, if every number is repeated 11 times, then that would be the number of unique numbers. Correct? Approximately. Again, you have to do an exact number because it has to be an integer, basically. But this is the extreme ends. Now, when I did this, I thought, okay, I need to find the exact integer also. But before doing that, I looked at the options and I saw that the options are pretty far apart. So I don't need to get the exact answer. If I can get a close enough answer and it's close enough to one of these options, I'm good. So I just did the approximate math. I saw it is 755, not 705, 755, this value. And this value, I just did it approximately. So I did long division, very simple, nothing fancy. Just do simple long division, guys. It's going to be 2 over here, approximately, yeah. So 22. And then it's going to be about 90. So 128 or whatever, like it's going to be around that number. I don't care about the exact number. Again, right now I don't care because I just want to see what is the approximate number I'm getting. It's possible that, okay, sorry, I've done a math mistake, right? Here, see, that's what happens with a lot of you, like in quick time when you're doing this question. So it is 130 something. Let's see. Okay. So it's going to be 137 approximately. But again, I don't care about the exact number as of now because when I subtract these two, I very clearly see the answer is in the vicinity of 600 something, but definitely less than 756. So my answer is D. So I don't really care a lot about the long division, doing it properly. At least the first digit I get, the moment I get 1 in the beginning, I know it is going to be 600 something. Okay, like 1 and 3 or 4 or 2, whatever, doesn't matter. The second number is going to be 2 or 3. That's what my mind was telling me. And I was like, okay, this is going to be definitely less than 750, definitely more than 600. Answer is 670. Let's move ahead. You don't need to do the exact math. If you do the exact math, you can't even say this is 137 because it will not be perfectly divisible. Then you have some leftover things. You'll have to think about how to adjust for that leftover. I'm not saying that it is going to be too time consuming to think of it. It might take another 10, 20 seconds, 30 seconds to do that. It's just 10, 20, 30 seconds. But why do I even invest that 10, 20, 30 seconds when I'm 100% sure that the answer is going to be 670? And that's what I call as awareness. Please understand, guys, I'm not trying to teach you to take shortcuts in life. Please understand, these risks that I'm asking you to take are not really risks. These are proper calculated decisions that you're taking. And if you are in the right mindset in the test, you are not completely rushing, and you are able to focus, you'll be able to make this calls very, very easily. Okay, trust me, it's an easy skill. I make sure my students learn this when we work together on the GMAT thing. But it's very important as a skill that you need to develop. Okay, now let's look at the last question. Okay, now this was a most difficult question here. Some of the people would be finding it very easy. I also found it very easy, but some people will find it difficult if you assume a certain things. For example, in this question, it just says, what is the probability that Martha wins the first 5 round, and loses the sixth? But there is no mention of what is happening in each round, what is the rule of the game, whether she basically what happens if she loses a round, what happens in the next round. There's nothing like that mentioned in the question. So if you assume that the probability of winning and probability of losing in a round is same, and work with that assumption, some of you might mark like the correct answer as C in this case. But if you don't know the rules of the game at all, and with that, if I go with the first statement, it says the chances that she wins in the first 4 rounds and loses in the fifth one is 1 by 32. You might do a mistake that if you assume that the winning chances of winning in every round is same, you might make a mistake here. It may not be the same. So you can't really use this equation. Even using the same logic, can't you make an equation from the second one either. You can't assume anything from the second one that her chance of winning in each round is the same or not. Nothing is given in the question. So the answer to this question is simply E. Had it been given in the question that her chances of winning in every round is the same, you can still form an equation, but still you would need to know that how the rounds function. So some rules for the game should definitely be written over here. Since there's no rule given, it's not mentioned which round it is, what is it she doing. If it was like she's tossing a coin and winning basically means getting ahead, you could use the probability understanding of events and everything to calculate it still. But in this case, there is no mention of that. So if you understand that logically, you'll not need to solve this question, and you'll understand the answer is going to be correct. Otherwise, you might make a mistake with this question, and that's why I said this is a hard question because of that reason. Some people might frame equations and still think that it will be solved. Okay, I hope that is all clear to all of you guys. So great, guys. I tried my best to kind of like give you the lessons that we had from the questions that we had. Obviously, like there are a lot of other questions which come on probability, permutation, combination, many more different varieties. It's a very broad topic. There are a lot of great things to learn from it. Whatever was possible with the limited questions that we had, then these questions were like handpicked by GMAT Club. We tried to focus on those questions. But yes, if you need any help with your GMAT preparation, you want to reach out to me, please feel free to connect on the details I've mentioned on the screen. If you have any other questions, feel free to open it up I'm opening it up for open-ended Q&A. You can ask me those questions. I'm here to help you out. I can take any questions that you want quickly. And in case you want to connect with me or my team, I help understand how GMAT Quiz can help you get your dream score. We work with a lot of students and help them get great scores and eventually get into great programs and scholarships. So feel free to reach out to us. I've given the link in the chat here. You can do that. Draw can also be a possibility. Yes, it could be a possibility. We don't have anything, Raksha, about the rules of the game. So if there is no mention of the rules of the games, we can't do anything about that. Okay. Thank you so much, Natasha, Rugved, Sid. I'm happy to know that you found the session helpful. I tried my best to. So I believe that math should be approached logically. If you approach it logically and you have an understanding of multiple things, multiple methods, and you strategize at the question, when you see the question, you always find yourself primed to kind of get even a perfect score in the quant section. Okay, so logic is what I believe in, and that is what I teach and preach. So yeah, I hope I was able to help you with some logical understanding of dealing with PNC and foundation combination today. Honestly, it's a very big domain. There are so many new type of questions also we have seen coming with the GMAT focus, and we're trying to train our students on better methods on the same as well. I've tried to do some of it today, so I hope it was helpful. So thank you so much, guys, and I'll be back again. I guess we have another quiz session in a couple of weeks, so I hope you will be staying tuned to it and attend the session as well. Okay, So see you guys. Have a good evening, good night, and good morning based on wherever you are. Thank you so much, guys.